Okay guys, welcome back. This is probably going to be the last lecture, a little series of videos. We're almost done, so that's a good thing. So let's try to get through it. So like I was saying, nuclear fusion is a process of splitting a nucleus into two nuclei with smaller masses. So U-235 to U-233, things like that. So come on. So the fission continues. So a larger nuclei with atomic numbers above 90 can undergo fusion. The lower ones can, but it's a lot more difficult, a lot more energy intense, and I'm not sure it's been replicated on a larger scale. So the product of fusion normally include 2 or 3 individual neutrons, with the total mass of the products is somewhat less than the mass of uranium-235, which makes sense. So the process that's hard to control is this chain reaction. So it's like a domino effect, but a domino that's exponential or logarithmic rather than one after another. So the chain reaction is an ongoing series of reactions. Billions of reactions occur each second in the chain reaction. So you have one neutron that hits the nucleus of a uranium atom, then it splits. Now you have 2 smaller ones with 2 or 3 more neutrons firing out, hitting more smaller things, and it just keeps growing and growing. So on Earth, nuclear fission takes place in a nuclear reactor, which is controlled normally in a pool of something to control the reaction, and you get this bluish glow, which is really cool looking. An uncontrolled chain reaction takes place during an explosion, like an atomic bomb. So we don't really want that. You can actually make an atomic bomb if you have around 2 bowling ball size pieces of uranium, and then you smash them together very hard in an explosive way, like you shoot one into the other. That's basically an atomic bomb. Cool, you're learning things. So fission products. So the products of nuclear fission reactions are radioactive, but the energy released from the reaction is less harmful to the environment than fossil fuels. So the byproduct is dangerous, the energy produced is less dangerous. So it's a trade-off. So the products are intensely radioactive and must be treated or stored. So this is kind of a comic, nuclear power is a good temporary option while we develop wind and solar power. Which is kind of true, I would say. We're starting to shift more so towards it. But if you wanted to replace a coal-fired power plant in Virginia with a solar farm, which the government of California just released, the National Science Foundation just released an article, a journal paper that the solar farms in California are more detrimental to the environment than nuclear power plants because of site locations and it's decreasing biodiversity, things like that. National Science Foundation, you can look that up. But the products, let's get back to nuclear, I'm sorry. But if you wanted to produce a solar farm that was large enough to replace one coal-fired power plant in Virginia, it would take up the square footage area of Washington, D.C. So that's not really an option at the moment. So let's move on to fusion. It's taking 2 smaller atoms and then combining them to form a larger mass. So it's a thermonuclear reaction, which we have not been able to do for longer, I think, than like nanoseconds here on Earth. Fusion reaction is how stars produce heat. Our sun is a really good example of a fusion reaction. It's almost impossible to create these reactions since Earth they need to be at temperatures above 1 million degrees Celsius in order to take place. Nuclear fusion produces less nuclear waste than nuclear fission, and the materials are easier to obtain, but once again we can't get to that temperature that we need. So let's talk about some major accidents in nuclear energy. Everyone knows of Chernobyl. Fukushima, Japan is recently. 3 Mile Island, a lot of people have heard of. Idaho Falls, maybe. Not many people have heard of the Switzerland one. So let's just go through the big ones. Chernobyl began during a routine test. Reactor 4 experienced an explosion because of a drastic spike in power. Directly, it resulted in 31 deaths. Considered to have resulted in more than 1 million deaths. A lot of the engineers at this plant sacrificed their lives to try to contain it more, which would have done a bigger mushroom cloud of radioactive junk. So everyone probably knows this picture more so. This is really famous. This is a close by town. the Ferris wheel. If anyone plays Call of Duty, this is an iconic little picture. Fukushima caused by a tsunami. Nuclear meltdown released radioactive material. 3 units in operation were affected. The other 3 were not. 30,000 people were evacuated, but the site still needs maintenance. They're not really sure of the total affected area count. Some drawbacks to nuclear energy. It's potentially dangerous. It's kind of expensive. The upkeep is there. And a lot of times it's used, the same technology to produce energy can be used for weapons. Nuclear waste has a long radioactive decay time, thousands and thousands of years. So this is the discussion, just food for thought, some things to think about. We don't actually have to do this since we're not going to have class, but think about small-scale pollution versus a large event. So let's say you have pollution from a coal mine, but you have a disaster like Chernobyl. Like what are the trade-offs? Is there one? Use as a weapon, is it a good idea to give this cheap electricity to, let's say, a developing country that may not be stable? It may have, a dictatorship. High cost for lower pollution. Are you willing to spend that extra money for the lower pollution? Would the world be willing to spend that? What about developing countries? Do we set the example? So things to think about there. The Kyoto Protocol, which would be a CO2 cap, was shut down. Things like that. You can do some research. That's a pretty interesting subject that we never get to pursue. So let's get into hydrogen. Should hydrogen be pursued as a fuel for the future? What are some of the major issues to overcome? What are the benefits of hydrogen? Excuse me. Do you think hydrogen will become the transportation fuel of the future? Is it reasonable to use hydrogen to generate electricity? So that's all the time I have today. You are more than welcome to contact me. My email is, let me write it right here, Joseph Amante at Virginia Tech, or you can do the shorter one. I do answer my emails religiously. It's probably like, I check it every hour or so. You're more than welcome to contact me. I'm sorry I couldn't make it in class. I had some other fun activities that we were going to talk about, but no one wants to do an activity via YouTube. So, like I said, email me if you have any questions. I will post the PowerPoint online for the class, so you have access to the slides. Thanks so much. I guess I'll see you guys around.